Hi, and welcome back to another lecture in Bio 24. In this one, we'll be talking about the biology of sleep. We spend about 1/3 of our lives sleeping. Sleep, in fact, is a required activity and is important for normal motor and cognitive function. It's required for survival, much like breathing oxygen, eating food, or drinking water. If anybody has problems sleeping, they develop difficulty concentrating, memory lapses, fatigue, and emotional instability. Approximately 100,000 car crashes every year occur in the United States from drivers who are asleep at the wheel. About 25% of drivers will fall asleep at the wheel at some point, and 50% of these are 25 years old or younger, indicating that even the youth of our country are not getting enough sleep. Sleep is accompanied by predictable physiological changes in the body. These can be detected by different electrical signals with instruments located around the body. Electrical signals can be measured in the brain, in the eye, and in the muscle tissue. These are known as EEGs, EOGs, and EMGs. EEG stands for electroencephalogram and involves an electrode being placed on the scalp in a symmetrical pattern. This measures small voltages caused by synchronized activity in the brain, specifically in synapses where there are nerve connections in the brain's outer layers or the cerebral cortex. EEG data are referred to as brainwaves. An EOG, or an electrooculogram, measures eye movement. It uses electrodes on the skin near the eye to measure changes in voltage as the eye rotates. Finally, there's EMG. EMG, or electromyograms, are used to measure activity in your skeletal muscles or muscles around the body. This involves electrodes that are placed on the skin overlaying a muscle. The electrodes are also placed under the chin because these muscles in your face change a lot during sleep as well. As you can see, there are in fact 3 different phases of sleep as indicated by these differences in electrical movement. There's the awake state, NREM, or non-rapid eye movement sleep, and rapid eye movement sleep, or REM. Typically, an individual will move from an awake state to an MREM state and then into a REM state. The EEG pattern of NREM sleep, as you can see from this image, is slower and more regular with higher voltage than during the awakened state. As the sleep gets deeper, however, the brain waves get slower and have greater amplitude. There are 4 stages of NREM sleep. Stage 1 is very light sleep. Stage 2 has special brain waves called sleep spindles or K-complexes, whereas stages 3 and 4 are increasingly more high voltage, slower waves. In NREM stage 4, it's extremely hard to be awakened by external stimuli. The muscle activity of NREM sleep is much lower, but muscles do retain their ability to function and still have a little bit of electrical activity. Eye movements do not normally occur during NREM sleep. The body's general physiology during these stages is fairly similar to the wakened state. But during REM sleep, things change substantially. The EEG recorded during REM sleep shows very fast and desynchronized activity. It's more random than that recorded during NREM sleep. REM sleep is characterized by bursts of rapid eye movements as indicated by the EOG. The eyes are not constantly moving, but they dart back and forth or up and down. They also stop for a while and then jerk back and forth again. Both eyes move together in the same direction. It's unknown as to why the eyes jerk back and forth like this. Some scientists believe the eye movements relate to visual images of dreams, but why they exist and what function they serve, if any, remain unknown. Additionally, while muscle tone is normal in NREM sleep, we are almost completely paralyzed in REM sleep. Skeletal muscles go limp as a result of hormonal signals being sent by the body. But while the skeletal muscles go limp, other important muscles in the body continue to function, including the heart, diaphragm, eye muscles, and smooth muscles of the digestive tract and other areas. Sleep is a cyclic process. During sleep, people experience repeated cycles of NREM and REM sleep. As mentioned, as you move from the awakened state into sleep, you first begin entering NREM sleep, going through the different stages 1 through 4 progressively. Eventually, you reach REM sleep. The cycle of NREM to REM sleep and completing that single cycle lasts approximately 90 to 110 minutes. Generally, in the course of a nighttime of a typical 8-hour sleep phase, this cycle is repeated 4 to 6 times. As night progresses, the NREM sleep amount decreases and the REM sleep increases. Physiological changes also occur during sleep. The endocrine system, which regulates hormone secretion in the body, is controlled by the circadian clock, which is an internal clock governed by 24-hour cycles entrained in the body. Many hormones are secreted into the blood during sleep. This includes the growth hormone, specifically important for adolescents, making sleep extremely important for adolescents, follicle-stimulating hormone and luteinizing hormone, which is used in female reproduction, making sleep extremely important for any woman interested in having a child, and the thyroid-stimulating hormone, which regulates eating, feeding cycles, and metabolism, meaning sleep is really important for regulating metabolism and maintaining a healthy weight. The renal system, which includes the kidneys, is also regulated and changes during sleep. Kidney filtration, plasma flow, and secretion of salt ions are all reduced in sleep. This causes urine to become more concentrated during sleep and is done so to allow you to sleep longer periods of time without having to get up and pee. Alimentary activity, or the gastrointestinal tract, is also regulated during sleep, where gastric acid secretion is reduced during sleep. This is, of course, a result of the fact that you don't eat while you're sleeping, and so you don't need gastric acids to be produced. Age also affects sleep more than any other natural factor. Newborns sleep an average of 16 to 18 hours per day. Children sleep 10 to 12 hours, and adults sleep 7 to 8 hours per night. A typical individual between the ages of 14 to 18 years are expected to get roughly 9 to 10 hours of sleep every night, whereas a young adult, 19 to 30 years old, is expected to get roughly 8 hours of sleep a night. This is accompanied by a reduction in the time spent in the deepest stages of NREM as you age. Newborns may spend about 50% of their total sleep time in REM sleep. In fact, unlike older children and adults, infants fall asleep directly into REM sleep. By 2 years of age, REM sleep accounts for only 20 to 25% of total sleep time, and this remains relatively constant throughout the remainder of the life. Young children have a high arousal threshold, meaning they can sleep through many loud noises. Some people even report the ability to vacuum around their infants and toddlers and not have their children wake up. Alzheimer's and Parkinson's disease are characterized by decreasing amounts of REM sleep, although it's unknown if the decreasing amounts of REM sleep contribute to progression of Alzheimer's and Parkinson's, or if Alzheimer's and Parkinson's are a consequence of REM sleep. Finally, elderly individuals exhibit more variation in duration and quality of sleep than do younger individuals, making elderly individuals more likely to nap during the daytime and complain about irregular or poor sleep patterns. However, for the most of the life of an average human, an adult is going to need about 8 hours of sleep. Some can be a little more, some can be a little less, but generally speaking, 7 to 9 hours is what a typical adult should aim for. Some individuals claim that they can sleep 5 or 6 hours fine every night, but in fact, no studies have indicated this is actually true. If someone continues to spend only 5 or 6 hours of sleep every night, a progressive sleep deficit occurs. Eventually, the body requires that the deficit be paid. Either this is in the form of poor health in the immune system, muscle building, cognitive function, or just general fatigue. Not getting enough sleep can still allow human bodies to function, just not at their optimal motor and cognitive abilities. People use caffeine or other stimulants to substitute for sleep, but these do not help counteract the effects of sleep deprivation. Health is still impacted, while some of the cognitive function disabilities can be masked. An internal biological clock regulates sleep for human beings. This is the circadian clock or circadian rhythm that we talked about before. This makes us sleepy at night and awake during the day. Our clock cycles with an approximately 24-hour period and is regulated by forces outside and inside the body. Forces outside the body, like the environmental factors such as sunlight or when we eat, these are referred to as exogenous sources. Whereas factors from inside the body, hormone regulation and mental function, are referred to as endogenous sources. The individual's sleep-wake cycle persists even in the absence of external cues. This shows us our circadian rhythm is influenced by endogenous factors or built in within our brain. However, external factors can impact the circadian rhythm and cause changes in our circadian cycle. One of the internal factors that regulates our circadian clock is the release of melatonin, a hormone which is controlled by the circadian clock in the brain. Melatonin levels rise during the night and decline at dawn. Administering melatonin can produce shifts in circadian rhythms and is regulated partly by light. Some individuals who are blind report having poor sleep patterns, and giving them melatonin can help regulate their biological clocks. Melatonin is also available as an over-the-counter nutritional supplement. There's current scientific debate about whether or not this may or may not actually help to promote sleep when taken as a pill, and the long-term use of side effects are unknown. Some people do take melatonin to help alleviate some sleep issues, which is what our next topic in our next section is going to be about.